Today we are gonna learn about probability concepts, which is from chapter number 5. So in this lecture we will discuss about probability. We will learn what is probability and what are the uses of probability. And moreover, we will talk about some approaches to assign probability. Similarly, we will discuss some important terminologies used in probability concept. We will learn about conditional probability and joint probability. These are two different types of probability. Furthermore, we will discuss about the rules of addition and multiplication to measure probabilities. And we will also talk about a tree diagram to organize and compute probabilities. And in the end of this lecture, we will talk about Bayes' theorem. So let's start with the probability. अच्छा, सबसे पहले आपको मैं एक प्रीवियस कॉन्सेप्ट के ऊपर बात करते चलें. Up till now, what we have learned in this subject, we learn about the data, how to collect data, and how to describe and organize the data. All of that is related to descriptive statistics. In the very first lecture, I told you how there are two different branches of statistics. One is descriptive statistics and one is inferential statistics. Uh, the techniques we have learned so far, like frequency distribution, central tendency, measurements, and so on. All these techniques are related to descriptive statistics. Now we are moving to inferential statistics. Inferential statistics is actually uh, related to uh, related to do decisions about future. So actually, inferential statistics provide us some basics and some information so that we can so that we can take its help in our decision making. So actually, inferential statistics help us in future decision making. And I told you earlier that we have a concept of sample and population. So in inferential statistics, we take a sample from population and then we take decisions about that population on the basis of sample. We apply some statistical tools and techniques on that sample and take decision about that population. One of the statistical technique to infer about the future decision making is probability. The very first concept of inferential statistics is probability. It's very important. We use this concept in our routine life, and it's very important in business. If we go by definition, then we can explain probability as the measure of likelihood of an event that it will happen in some future time. And in total, the value of probability is 1, and the lowest value of probability is 0. When there is no probability, we say it's 0. And the highest level of probability is 1. 1 means, in other words, we can say it's 100%. Like when we say the chances of rain is 20%, 0.20, or the chances that sun will not come out tomorrow is, for example, 0.60 or 60% chances. This is how we uh, calculate probability. So there are some scientific methods to calculate probability. We will discuss those in detail. There are three ways to calculate or assign a probability. One is classical, other one is empirical, and the last one is subjective. We will discuss these three types of probability concepts in detail in later section. Let's move to an example. You can see there is a scale from zero point 0.00 to 1.0. 0.00 that uh, the probability of something is zero or cannot happen, that the thing is not gonna happen, and 1.00 probability shows that surely it will happen, like you are 100% sure. And there are some examples underneath this scale. You can see probability or our sun will disappear this year, मतलब कि हमारा सूरज जो है वो नहीं रहेगा, खत्म हो जाएगा, नजर नहीं आया करेगा. What is the probability of this? So we can say that this is a 0% chance that sun will disappear. The probability is 0 0. Similarly, 0.50 chances of a head in a single toss of coin. कॉइन आप अक्सर क्रिकेट मैच खेलते होंगे और कॉइन टॉस करते हैं, तो एक वन साइड ऑफ द कॉइन इज हेड, another side of the coin is tail. So when you toss a coin, and you can see you can either get a head or a tail. So in that case, there is a 50% chance that head will come and 50% chance a tail will come. So 0.50 is the probability that a head will face up when you toss a coin. I think it's pretty simple if you get my point. Okay, there are some important terminologies used in statistics or in probability concepts. One is experiment, outcome, and event. Experiment actually is the process of observing an activity. For example, uh, I have a coin and I'm going to observe, like we are going to play a cricket match, and who will who will bat first. For that, to decide who will bat first, we will toss a coin, and the winner will get batting. So there are two sides of a coin. One is head, one is tail. Some will call head, one captain will call head, and one captain will call tail. When we'll toss a coin, the process of tossing the coin is called experiment. An outcome is when you will have that coin on the floor, the side which will face up, there are two outcomes, head and tail, and there would be only one outcome. So either it is head or tail, this would be a outcome. For instance, we say it was head, so this is an outcome. Event is the collection of one or more outcome of an experiment. I will explain this terminology by an example. Look at this example. You are very well aware of Ludo. सब लोग खेलते हैं. So लूडो में आप क्या करते हैं? You roll a die और उस पर जो नंबर आते हैं वो उसको आप ऑब्जर्व करते हैं. जो भी नंबर आते हैं उसके आस पास अपनी बारी चलती है. तो हम लूडो की बाकी गेम को एग्जाम करते हुए we just discuss the process of rolling a die. अब आप जब एक डाई को रोल करते हैं तो इससे पहले you know there are 6 sides of that die, and one side appears 1, another side shows 2, 3, 4, 5, and 6. In total, there are 6 sides, and each side has different number ranging from 1 to 6. So, when you roll a die, this is an experiment. And what are the possible outcomes? It could be face up 1, could be face up 2, could be face up 3, could be face up 4, up to 6. You never know which number will face up. So all 6 possible outcomes. एक डाई की 6 ही साइड्स होती है, तो 6 साइड्स की जो पॉसिबल आउटकम्स हैं वो 6 है. So all the collection of all these possible outcomes is called 6, as you can see in this example, second row of uh, this chart. The 1, 2, 3, 4, 5, and 6. This is a collection of total outcomes, all possible outcomes. So these are outcomes and possible events. For example, we are observing an even number, and you know that even number is how many even number in this case? There are three even numbers and three odd numbers. So you can either uh, observe uh, even number like 2, 4, or 6. These are possible events. So आप ये भी देख सकते हैं, आप इसमें हो सकता है दो आ जाए, चार आए या छः आए. So these are some possible events when you are observing this experiment. और इसी तरह this is called event. And इसी तरह we are gonna observe a number greater than 4. So in that case, you will have an outcome of 4, 5, and 6. There are three possible outcomes. So these could be possible events. The event could be give you a number greater than 4. और ये भी हो सकता है कि हम ये एक्सपेरिमेंट एक से ज़्यादा मरतबा करें. फॉर एग्जाम्पल वी डाई अ रोल फॉर 5 times or 10 times, and then we want to observe that whether the number was greater than 4, how many times the number was greater than 4. For example, we say that only one time the number greater than 4 was face up. So things like that. Now we move on. How we assign the probabilities? Three ways, as I told you earlier: classical, empirical, and subjective. Actually, there are two types of probabilities. One is objective probability, another one is subjective probability. Objective probability is further subdivided into two categories: classical probability or classical approach, and other one is empirical approach. And the other technique is subjective probability. So, what is classical probability? As by name, it's a classic way to assign or measure the probability of an event. For consider we were having an example of rolling a die, and you know there are 6 sides or 6 possible outcomes of a die ranging from 1 to 6. So, what is the probability that uh, one will face up, on what is the probability two will be face up? For example, we select 2. So we want to measure what is the probability 2 will face up, या in simple words कि आप एक इस die को रोल करेंगे, और रोल करने से पहले you want to measure that what is the probability कि 2 आएगा. फॉर एग्जाम्पल आपको दो दो नंबर की ज़रूरत है, तो आप इसको रोल करेंगे डाई को, और आप ये देखना चाहते हैं कि ये 2 नंबर आने की क्या प्रोबेबिलिटी है. तो क्लासिकल प्रोबेबिलिटी हमें इसके लिए एक मैथमेटिकल वे देती है कि हम कैसे अपनी प्रोबेबिलिटीज को मेजर कर सकते हैं. सो what we will do, we will divide the number of favorable outcomes with the total number of possible outcomes. So in this case, how many favorable outcomes? Like there are only 6 sides or 6 possible outcomes, and our possible outcomes is 6. So in this formula, you can see in numerator we will write 6. But number of favorable outcomes, how we will define number of favorable outcomes? You know, we are interested in number 2. So ऑन दीज 6 साइड्स, इन 6 साइड्स पर कितनी दफ़ा 2 नंबर लिखा हुआ है? सिर्फ एक दफ़ा। सो एक ही है हमारे पास। दो दो के आने के चांसेस जो इन सब में एक दफ़ा है। सो वी विल राइट इट लाइक 2 सॉरी 1/6। जो आंसर होगा दैट वुड बी probability of an event, probability that a two will face up. This is an event. This is the way to measure the probability. This is a classical way. Number two, we can also, another example, we can also measure uh, the probability of an even number, right? Like how many even numbers are there? There are three even numbers and three odd numbers. So if we want to measure the probability of even number, 2, 4 and 6, there are three even numbers. इन तीनों में से कोई भी आ जाए दैट वुड बी इवन नंबर। तो कितने इवन नंबर्स हैं हमारे पास? चांसेस क्या है इवन नंबर के? टोटल फेवरेबल आउटकम्स हमारे पास इवन नंबर के क्या है? दीज आर 3। सो टोटल नंबर ऑफ पॉसिबल आउटकम्स क्या है? दोज आर 6। वी विल डिवाइड दिस 3 with 6 and the result would be the probability of an even number in this event. Hope you understand this concept. There are two more important aspects in probability concept. One is mutually exclusive. If you recall your memory, while we were measuring frequency distribution, we talk about this mutually exclusive. Mutually exclusive means the categories are uh, actually independent from each other. There is no overlap between categories. So here this concept is known as the occurrence of any one event means that none of the other can occur at the same time. For example, when we roll a die, only one event will occur. Like if we are observing even number, it is not possible that even number and odd number both will come up in that experiment. Or if we take the example of that toss a coin, while tossing the coin, we have only two outcomes. One is head and one is tail. So when we will toss the coin, and the outcome would be only one, either head or tail. And it is not possible that tail and head will come, both will come at the same time. So we should understand when we are measuring probabilities, the events are mutually exclusive. If events are not mutually exclusive, then the case would be changed. And events are independent if the occurrence of one event does not affect the occurrence of another event. Then these are independent, and these are two different things. Mutually exclusive is another thing. In mutually exclusive, the one when one event is happening, the other cannot. And in independent, the happening of one event will not affect the occurrence of an other event. Now, move to our next topic. Other one is collectively exhaustive. This is the same concept we discuss in frequency distribution. Collectively exhaustive is at least uh, in frequency distribution, we took it like one observation should be included in one category, and there is no unattended observation. So this is here in this probability concept, at least one of the event must occur when an experiment is conducted. Like when we roll a die, there should be one outcome. we cannot say that there is no outcome. Or when we will toss a coin, there is there would be at least one outcome, like it would be head or tail. We cannot say that there is no head and no tail. This is not possible. Similarly, in rolling a die, this is not possible. We can say that there is no number, because uh, at least one side will face up. So it would be ranging from 1 to 6, but should be one outcome. So at least one outcome should be there. This is collectively exhaustive. Now the other type of probability is empirical probability. Empirical probability is depending on the previous data, like the number of times an event has been happened in past or previous time. And this concept is based on the law of large number. The more observations we have, the more accurate estimation of probability we can measure. And what is this law of large number? Let me explain you with this example. Look at this example. In the very first column on the left side, you can see number of trials. Number of trial when we do one trial, like we are tossing a coin, and there are two sides of coin, head and tails, and we are going to observe number of heads, how many times heads will show up. So we toss a coin one time, and at that time head didn't face up and tails face up, so the frequency or relative frequency of head is zero point 0.00, because we didn't found that outcome. Okay, another one is we toss the coin for 10 times and we count how many times head show face up. So we found that three times this the head face up in 10 trials. So the relative frequency of the head is 0.30. आपने पहले ये पढ़ी हुई है फ्रीक्वेंसी डिस्ट्रीब्यूशन में. relative frequency क्या होती है? Number of frequency divide sorry frequency of that particular class divided by total frequency, so we can find out relative frequency. So the relative frequency is just like probability. And if we increase our number of trials from 10 to 50, you can see number of heads increase to 26. So when we were having only one trial, we observed that head face up will only one time. Then when we do this, when we toss the coin 10 times, we got number of heads three times. And when we toss the coin 50 times, we found that number of heads face show up 26 times, and the relative frequency is 0.52. And similarly, if we you can see if we increase the number of trials, we are having some more bigger and accurate result. So this shows that more data or more observation will give you uh, better uh, results for your probability calculations. Okay, now move on. Now come to empirical probability. This was the concept of law of large number. So law of large number is important for empirical probability to just to understand the concept of empirical and probability. Now we move to measurement of empirical probability. There is an example that, as you know, NASA sent some space mission to space, and they have sent, in this example, you can see they have sent 113 space missions. These are total number of space missions. Out of 113 space missions, two flights or two space missions were exploded. So two times they failed, and 111 times the mission was successful. We want to find out the probability, like they are gonna send a new mission, and they want to find out the probability of the success of that mission, that how many chances, or what is the probability that their next mission will be successful or failed. So we are interested in measuring the probability of successful flights or successful missions. So what is the mathematical way to find out this? We will divide total number of successful flights or missions with total number of flights. So in this example, you can see total number of space missions were 113 and successful missions were 111. As I told you earlier, that two space missions were exploded or failed. So out of 113 missions, two were failed. So successful missions were 111. So if we divide 111 by 113, the answer would be 0.98. It means it is 98% possibility that their new mission will be successfully completed. Or probability, we can say 0.98 probability to successfully completion of the new mission. Similarly, another way we can use this same example for the measurement of failed flights probability. So if we turn it other way, the probability of failed flights, uh, how many failed flights were in this case? There were two failed flights out of 113. Two space missions were exploded. So 2 divided by total number of flights 113, it would be 0.02. So we can say that it is only 0.02 percent or 2% chances that the new mission will be failed. The other concept of probability is subjective probability. The previous two probability concepts are based on uh, data. One is classical, another one is empirical. Empirical is based on past data, previously, the number of times event happened, and the classical approach of the probability is actually the number of favorable outcomes, uh, division of number of favorable outcome with total outcome. This approach is little bit different from those. Subjective probability is does not have any specific way or technique to measure the probability. Rather, it is depend on the experience. It is depend on the gut feeling. It depends on the whatever information available. When we don't have any uh, past information, or we don't have any specific way to find out the possibility that something will happen, we have no information about that event, then we use this subjective probability. So in this example, there are three example. Number two, you look at that example number two, estimating the likelihood you will be married before the age of 30. अब ये चाहते तो सारे हैं, लेकिन पता किसी को नहीं है. So you don't have any past experience. So it's not possible to measure this type of probability by classical or empirical approach. This would be on the basis of information and your planning or someone else information. किसी का इंडिविजुअल एक्सपीरियंस हो सकता है, दिस कुड बी योर एक्सपीरियंस. तो इसकी बेस पर आप ये कर सकते हैं. Similarly, possibility that you guys will pass this course, business statistics, with A grade. So you haven't passed business statistics before. So this is your first time. No previous information is available, and there is no such chances. to measure that probability with classical approach. So you can have some information. For example, you can find out on the basis of your experience, on the basis of your understanding with the subject, on the basis of your quiz or assignment marks. So you can make some probability that I will have a A grade. I have 0.7% chances or zero point 0.7 probability. So let's move on the uh, summarize these three probability concepts. Uh, we learn that there are two basic concepts of probability. One is objective, another one is subjective. And for objective, we further divide it into two categories. Excuse me, classical probability and empirical probability. Classical probability is based on the equally likely outcomes. Classical, when you have a data on the or one some event in some event, the likelihood of outcomes are equal, then we use classical probability. Excuse me, give me a minute. Okay. And the other concept, that is empirical probability, is based on relative frequencies, and we just have discussed this concept. And subjective is based on any information available. It could be experience or observation or something like that. Okay, now move on to another important aspect of this probability concept. So this is the rule of addition. So there are two rules. One is rule of addition, another one is rule of multiplication. Rule of addition: when two events are mutually exclusive, we use this rule of addition. So we are moving towards adding the possibilities or probabilities of two or more events. When two or more events are mutually exclusive, and what does it mean by mutually exclusive? Mutually exclusive means that uh, only one outcome will come or will occur at the same time. Like in our case, when where we were tossing a coin or we were rolling a die. So, how to measure, how to add the probability of two events? The mathematical equation is written as probability of A or B. You need to understand this operator or. Or is used to add the probabilities. Or is the operator for addition. So probability of A or B is equal to probability of A plus probability of B. For example, we were discussing about let's have example later. So this is the rule of addition. I will explain this in detail in next example. There is another general rule of addition. If A and B, two events, are not mutually exclusive. The first one was rule of addition for mutually exclusive events, and it is also called special rule of addition. Special rule of addition is for mutually exclusive events, and when two events are not mutually exclusive, we use general rule of addition. So general rule of addition equation is stated as probability of A or B is equal to probability of A plus probability of B minus probability of A and B. Probability of A and B means the probability that both events will come together or occur at the same time will be subtracted from the added probability of event A and B. As you can see in this picture, this is a Venn diagram, and this shows that two events A and B. Uh, Green one is B, the down picture over on the left side and left down corner. Left one is purple one, that can be named as event A, and right one is event B. And you can see these two circles are have some shared part that is showed by orange color. So this is the probability of these two events, which can be occur at the same time. I will explain it later with an example. Look at this example. All of you are aware of playing cards. ये जो आप ताश के पत्ते जो होते हैं आप सब लोग जानते हैं. There are 52 cards. आपने क्या करना है, आप लोगों ने आज जाके पहले ये एक खरीद लेना है, इसका एक पैक ले लेना है आपने प्लेइंग कार्ड्स का. आपने देखना है कि उसके अंदर टोटल कितने कार्ड हैं. देयर आर 52 कार्ड्स. और आप देखेंगे कि उसके अंदर 4 ग्रुप्स होते हैं. एक हार्ट होता है, उसमें से एक हार्ट होता है, एक कोई और नाम है, एक कोई ब्रिक होता है, और इस तरह 4 होते हैं डिफरेंट नेम्स. अच्छा, उसी तरह आप उसमें देखेंगे तो उसमें कार्ड्स होंगे फ्रॉम ए. ए के 4 कार्ड्स होंगे, 1 के 4 कार्ड्स होंगे, 2 के 4 कार्ड्स होंगे, 3 के 4 कार्ड्स होंगे, अप टू 10. एंड देन उसके अंदर एक किंग होगा, क्वीन होगा और जैकल होगा. आई थिंक के किंग क्वीन एंड जे जैक जैक आई थिंक. सो किंग के भी 4 कार्ड्स होते हैं, क्वीन के भी 4 कार्ड्स होते हैं, जैक के भी 4 कार्ड्स होते हैं, 1 के भी 4 कार्ड्स होते हैं, 2 के भी 4 कार्ड्स होते हैं. और हर कार्ड जो है वो हर उस कैटेगरी से होता है जो मैंने पहले बताया, दैट इज वन इज हार्ट एंड वन इज ब्रिक एंड टू अदर ग्रुप्स. आई डोंट रिमेंबर द नेम. नाउ our example is or our question is, uh, we want to measure the probability that from that deck of card we will pick a card from that deck of card, and what is the chance that that card we are going to pick would be a king or a heart. We have two possible outcomes, or we want to measure the probability of two events that the card we are going to take from that deck is king or a heart. So what is the way? First, we have to measure the probability of each event. So one event is king and the other event is heart. I told you there are 4 king cards in that deck of cards. And total number of cards in that deck is 52. So how to find out the probability? 4 divided by 52, because there are 4 kings in a deck of 52 cards. So the other event is heart. So there are how many cards in that deck? There are 13 cards of heart in that deck of 52 cards. So 13 is favorable outcomes divided by total number of outcomes, that is 52. And the last one is king of heart, that is happening of A and B at the same time. What is the probability that event A and B will occur at the same time? So there is a king of card of heart. The probability of that, there is only one king of heart. So 1 over 52. Now we will uh, use that rule of addition, that is general rule of addition. So 4 divided by 52 plus 13 divided by 52 minus 1 over 52. 1 over 52 is the possibility of event A and event B. And if we calculate this equation, we will get the number 0.3077. So there is a 30.77% chance that when we will take a card of king from that deck, take a card from that deck, either it would be king or a heart. Now move on next. I think you have understand this. If you have any problem, we can discuss in later session. There is another rule that is called complement rule. Complement actually is the negation of an event. So here you can see there is an event, and if we plus uh, a probability of some event, and if we add the probability of not happening that event, that would be equal 1. For example, we toss a coin. What is the probability that head will face up, and what is the probability that tail will face up? We can find out these probabilities by dividing the favorable outcome with total number of outcomes. When we will toss a coin, the total number of outcomes are 2, head and tail. And favorable outcome, what we gonna observe, that we gonna observe head. So what is the probability of that head? That is 1. Only there is only one possibility that head will show up. So 1 divided by 2, it is 0.50. So if we plus this 0.50 with not happening of A, so we can find that the total probability will be 1. So in other case, like हम ये देखना चाहते हैं कि हेड के आने की प्रोबेबिलिटी हमें पता है, लेकिन हमें ये नहीं पता कि हेड के टेल के ना आने की प्रोबेबिलिटी क्या होगी। तो टेल के ना आने की प्रोबेबिलिटी इज हेड के आने की प्रोबेबिलिटी है। तो अगर आपने ये फाइंड आउट करना हो कि टेल के आने की प्रोबेबिलिटी क्या है, तो आप टेल के आने की प्रोबेबिलिटी कैसे फाइंड आउट कर सकते हैं? प्रोबेबिलिटी ऑफ इवेंट, फॉर एग्जांपल वो उसको हम ए कह लें, टेल आने के जो चांसेस है, दैट इज प्रोबेबिलिटी ए इज इक्वल टू 1 माइनस probability of not coming, that is not occurrence of B. तो हम इस तरह से फाइंड आउट कर सकते हैं हेड आने के चांसेस या टेल आने के चांसेस। किस तरह किसी भी चीज़, किसी भी इवेंट की प्रोबेबिलिटी हम फाइंड आउट कर सकते हैं अगर हम क्या करें, 1 में से उसका कंप्लीमेंट माइनस कर दें। तो कंप्लीमेंट क्या है? नॉट अक्रंस ऑफ ए। नॉट अक्रंस ऑफ ए इज एक्चुअली द अक्रंस ऑफ इवेंट बी और सी और डी। So not occurrence of some event would be subtracted from one, and we can find out the probability of that event. This is a Venn diagram example. Here you can see joint probability concept. Uh, you can see there is an event A. In our case, in our previous example, A was uh, king, card of king, and event B was uh, card of heart. As we uh, discussed earlier, there are 4 king cards and there were 13 heart cards, and there was only one king of heart. So you can, by this example, you can understand that event A, event B, and the occurrence of both event A and B at the same time. So this one diagram can show that concept. Now we move to rule of multiplication. There is a special rule of multiplication, and there are some prerequisites to apply that rule. The rule can be applied when two or more events are independent. They are not depending on each other. For example, we are tossing a coin, so the two events, head and tail, they have dependence on each other. If head will show face up, tail will not show face up. tail will show face up, head will not show face up. So we cannot apply rule of multiplication on uh, tossing the coin example. For this, we need some independent events. So for independent events, the events could be uh, happened at different times, or there are more than one events that are independent. For example, we are tossing two coins. These, these are two independent events. So coin, for example, coin A and coin B. So we are tossing two coins at the same time. We rolling dice, two dice at the same time. So these two events are independent. We can apply a rule of multiplication on these type of examples. And how we can measure the rule of multiplication or multiply the probability of two events. You can see the mathematical equation down here. Probability of event A and B would be equal to probability of A and probability of B, and this is product, probability of A multiplied by probability of B. So in addition, we add the probability of two events, and here we are gonna multiply the probability of two events. And you can see the operator over here is and is used for multiplication, and or is used for addition. Look at this example. This is a this is a data related to American Automobile Association. 60% of its members made airline reservation last year. Two members are selected at random. What is the possibility or probability that both made airline reservation last year? So we will use a rule of multiplication. How we use it? The probability first member made an airline reservation last year is zero point 0.6. So we denote it as probability of R1 is zero point 0.6. The probability that the second member select selected, they select two members. So second member made a reservation last year is also zero point 0.6. So probability of R2 is zero point 0.6. So since the number of members is very large, you may assume that R1 and R2 are independent, because they happening that there are 60% members they made reservation. So maybe the 60 out of those, for example, total number of members were, for example, 10,000, and out of those 10,000, 60% of members made airline reservation last year. So it means 6,000 members made reservation last year, and out of those 6,000, or those total 10,000 members, we got these two people. We select these two people, and we are gonna measure the probability. So we know that the if one person made reservation, it is not depending on the reservation of other member. ये कोई ऐसा सिलसिला नहीं है कि एक मेंबर जो है वो टिकट रिजर्व कराता है, दूसरा नहीं कराएगा. ये दोनों एक इंडिपेंडेंट हैं एक दूसरे से, और एक की रिजर्वेशन से दूसरे को कोई फर्क नहीं पड़ता है. सो ये हम इसको कह सकते हैं कि ये एक इंडिपेंडेंट इवेंट है. अच्छा, तो now the probability of these two events would be, when events are independent, it is probability of event A multiplied by probability of event B. So if we multiply the probability of these two events, it would be 0.36. So this is how we measure or multiply the probability of two independent events. I hope you have understand these concepts. Now I will send the assignment in this